It's been so long. And we're live.
Hello,
Hey,
good
good morning,
morning.
Justin. How you doing
Good
today?
morning. Good. How you doing?
Excellent, excellent. We're lamenting our lack of fast food.
Yeah.
Uh,
Planning a trip to Wendy's.
Planning to the Wendy's. So very exciting stuff here. Um, hey, and so I think we have a pretty cool topic today. It's one of that's really exciting about cloud storage. It kind of came out of our discussion last week about like on-premise storage. It's kind of the natural next session. And what we wanted to do was kind of demystify some of the cloud storage. There's a lot of unknown knowns and marketing and buzz and use case things. And so we want to kind of make it like a really easy primer for people to understand different styles of cloud storage and different use cases so that you can make some good informed choices.
Mhm.
Beside that, thanks a lot for liking and subscribing. It's been great. We get some really great feedback from people. They seem to be enjoying them. As I said, the best feedback is when people say, "Hey, I used it to help me do whatever it is that they were looking to do," and they used some of our content, which is great, being helpful. So let's dive right in here,
Yeah.
and it's kind of and I think you and I should just do this kind of back and forth. So I'll kind of ask a question, I'll throw it back in at you,
Sure.
and then we'll go from there. All right, so why use cloud storage? Kind of like, what is the use case? What is why would I need this? Why is it
Um,
better? What is it?
yeah. So, I mean, we've said before, the best definition I like of the cloud is just somebody else's computer. So,
Yeah,
it, good to keep that in mind. That cloud is a term that gets thrown around for a lot of things, and
right,
really, what the key stuff to think of is that it's not your equipment and it's somewhere not in your office. That really is the key
right,
pieces of it. So why you would use that for storage? Few reasons. The first one being because it's not your computer, it's somebody else's. It's built to be highly available. So it is. Well, we were talking last week about RAID and having all the different disk configurations to make sure that you could survive a
right,
disk
right,
failing. You look at places like Azure or AWS or Google Cloud, that type of build is out at super big scale. They can
right.
lose entire servers and you would never notice because it's built to be uh, uh, scalable and resilient like that.
Right. So you're kind of taking away all the know-how needed to kind of manage that redundancy in the system. You kind
Right.
of you're buying that as part of your upfront cost. Is
Yeah.
that resiliency and know-how of getting it to work properly without
Right.
having to do
Mhm.
anything? Right.
Yeah, you can buy just what you need and trust that underneath it it's being protected and being built out in that scalable set.
Right.
The other piece of it is it doesn't rely on your local network, your local stuff. So same thing if you've got a uh, server that you've built in your office and you want people to connect into it remotely, it relies on your office having power, having heating and cooling, having internet, all of those things.
And
And
most importantly, electricity.
yeah,
I
power,
mean, it's
all of
that
that stuff.
power. It's like I think the big one.
And yeah, so rather than building data center like redundancy into your office, you can leverage these data centers that are already built that are set up for that. So the
Right.
the odds of your office losing internet much higher than the odds of Microsoft or Amazon or Google losing internet.
Correct.
It's
Right.
doesn't rely on those local conditions. And then the third one, which is tied into the price, is that cloud storage is generally considered infinitely expandable, which is, if you have whatever storage you build locally, you try to plan for more than you have now, not less than you're going to need, but somewhere in the middle, and hope that by the time you need more storage, it's time to buy a new system anyway.
Right. Right.
Whereas with cloud, you can just get exactly how much you need when you need it. And when you need more, you can pay for more. And if you need less, you can scale back and pay for less. So it's
Right.
that scalable and that ability to grow and that dynamic size.
I think it's really important to other thing to think about when you're looking at pricing in
Mhm.
cloud, that not only you're just paying for like the thing you're using, but you're paying for all the underlying pieces. And I think
Mhm.
you kind of touched on that earlier when you said about the power and the cooling and working, and when you to build your own data center or even to rent a piece of a data center, is unbelievably expensive. We've done it in the past.
Mhm.
We do it for some certain customers based on need, and it gets really expensive really fast. So little pieces you need, like KVM switches and that kind of thing, load balancers, and you
Right.
name it, and you're kind of buying all that pre-packaged and pre-built so you can focus on the one
Mhm.
thing that really matters, which is your application or delivering services to your clients and or users.
Mhm.
So this way, I just to kind of put a wrapper on it, is that cloud is not necessarily less expensive. It can be even more expensive at times, but it gives
Yeah.
you a lot more flexibility and operational availability. So you
Yeah.
can always be working, and you can eliminate that concern, but not your responsibility. But we'll get to that in a second.
Yeah.
Very
Yeah.
important to keep in mind your responsibility. So, with that in mind, just kind of saying like, hey, why? Um, what are the different core, broadly, different
Mhm.
types of cloud storages? Because I think
Yeah.
there's a lot of confusion here. I know myself. I feel this question quite a bit, even to this day, and we've been doing cloud for like 5+ years now. And
Mhm.
sometimes I think it's really hard to sum it up in a way. So I think this is pretty cool that I think it'd be cool to have it like, hey, this is here,
Yeah.
here, and here.
This is what
So
cloud
this is what.
storage. Yeah.
So I'm going to kick it off. So, what are the different kind of storage types?
So there's a bunch. What we've got here are from Microsoft site, from Azure, different types of storage. The uh,
Right.
the two on this list that we're really going to focus on are the first and the last,
Hmm.
blob storage and file storage. The other two, table storage and queue storage, are specific for types of database or types of applications. The
Right.
important thing uh, uh, for those is that it's meant for applications, not for people.
Right.
The first one that we're going to look at, file storage, that one is meant for people, for users. And file storage, you can think of like the standard, files and folders. Think about Dropbox or OneDrive or Google Drive
Right.
or a server share. Those are file storages. You're putting files in, you're accessing them. They usually have some type of sync tool to sync it down to your machine, so you don't need
Hmm.
anything fancy to connect to them, or you could go into a browser to get access to stuff.
Right.
And very, very good for user data. It's not necessarily the cheapest when it comes to storage options. A lot of times you pay per user instead of for total storage, or you pay for a total storage amount, and depending on what service it is. But
Right.
it has that wrapper around it of files and folders and things that you're used to working with.
Gotcha. That makes a lot of sense.
Um,
So that's basically like replacing my file server,
right.
correct? That's
Mhm.
basically, if you think about it, the file storage, like different versions of Dropbox and or Azure File Sync and OneDrive, also, they're basically just for files.
Yeah.
And
Yep.
and so my Word files and my Excels and PDFs and pictures, that's what goes there,
Right.
correct?
Exactly.
Okay,
Yep.
got it. So,
The
uh,
next one
mhm,
is a little more complicated, and that is called either blob storage or object storage. Blob is really a term. It's binary large object, and
okay,
it's meant to be accessed by programs, not necessarily by people. So the
right.
idea with object storage is that instead of putting everything into files and folders, you take the data, you take what's called the metadata, which is information about what that data is. You
Hmm.
have all of those things wrapped together into one object, and you put that in. It's called a flat storage environment. So there's
Right.
no folders, there really aren't file names. There are file names in that metadata, but it's not meant for people to access. It's meant for programs to access.
Right.
So because of that, for programs, it's very easy for them to search because the metadata is there to find specific things to jump around and get data that it needs. And it can be very fast because it doesn't have to go through folders. It can go direct to, I know this object's address, so I can go to just that object, which
Right.
is the data that I need as a
So
program.
so I can recall it back without having to traverse through these
Mhm.
different hierarchies, right? Because
Right.
as
Yeah.
by idea of flat, it means it's not nestled within files or folders, kind
Right.
of using the old school file cabinet example, which I think is always still pertinent here, is
Yeah.
that this is like, imagine if it was a giant, this lake of stuff
Yeah.
thrown in, and but you can find it because it has a tag on it.
Yeah, each
Whereas
one has its own unique identifier, and the
right,
program that you're using to get those files knows which thing it's looking for. And
got
if
it,
it's searching for things, like if you say, I don't know, I want all the things that are labeled like this, it can search through all those labels and bring those things back to you. So there are programs that make it look like it's in folders by saying, I'm going to make a label on it and I'm going to interpret that label as a folder. But at the end of the day, it's flat. So it's the this is where you see a lot of the cheaper storage options.
right,
Get into some of those, but that's not meant for people to interact with. It's really meant for programs. So this is good for things like storing web content or storing application content or storing data that you would otherwise put in a database if it was file data and you need to
right,
get, you can put here. And that's where a lot of the cloud storage pieces come in, is that there's a piece of software that translates what you're doing into what the cloud is doing, and can you kind of work between those two things to be able to
right,
leverage that storage.
right.
And
Which
then
and then
the third one I just want to mention is called disk or block storage, and that's for machines, for computers. So if
right,
you want to have a server running in the cloud, you would put a virtual hard drive on that server that's going to be block storage, and
right,
that's built out differently than object storage or file storage. It's just like,
right.
here's a chunk of data of space, and you can write to it ones and zeros to it and do whatever you want with it.
And basically that has the highest cost, correct? Because that is directly attached to you. Is that why that is, you can
It's
only use it, sort of?
it's not always the highest cost. It depends. I mean, like all
Okay.
things, it depends, because there's a lot of different ways. Like you could build let's say you wanted to build an Azure file storage, which gives
Hmm.
you a share that you can put on your computer. You could also add to that backup and global redundancy and premium, so it's on faster disks and all these pieces, and that could come out to be way more expensive than a similarly sized block disk that's just in one place and
Right,
you're not backing it up, or you're doing it. So it all depends on how you put it out. But in the per gig, usually the in a full cloud provider, find that the file storage is the more expensive one.
got it.
Uh, Only because it's either all these layers on top of it, or it's billed per user for something like Dropbox. So you
Gotcha.
might
That
get
makes sense.
unlimited storage in Dropbox, but if you need 100 users in it, it's going to be more expensive than
Right.
something
If
else.
if you calculate your per terabyte costs, it
Right.
might be really pricey per terabyte because not everyone uses all that unlimited data.
Exactly.
Got it. That makes perfect sense.
Mhm,
And so now we kind of define like the file, object,
mhm,
block. What are there tiers within those systems?
mhm.
How do they tier? How do they, in terms of like use
Yeah.
case, cost, that sort of
And this is where it starts to get interesting in how you build things out. So generally speaking, there's a few different tiers of data: hot, cold, and archive. And the terms are different for different providers, but they generally are the same thing. Where hot is data that you're accessing, modifying, writing to frequently. Cold or cool is data that you are storing relatively long term and not changing, but you are still accessing. An archive is, I don't want to see this. I don't want to think about it. I just need to get it. I just need
thing?
to know that I have it if something happens. And
Right.
the differences between them are in price and performance and how you use them. So for hot storage, it's going to cost you more per gig to store that, but it'll cost you less to do like transactions. And in object storage, a lot of times you get charged not just for storage, but what you do with that storage. So if I'm going to write to that data, there's another charge that goes with it, versus reading the data versus deleting the data.
Right.
So hot generally is the most expensive to store, but the least expensive to do stuff with. Cool is in the middle, where a lot of times there's limits on, like, if you put data in, you can't delete it for a certain amount of time. It has to stay there.
Right.
And if you modify it, you get charged more, but it costs less to just keep it. And then archive is the full on opposite of that. It's really cheap to store it, but if you need to get it, be prepared to pay to get it out in a timely manner.
So a good real world example, I go back to our file cabinet, but it's
Yeah.
sometimes how I like to think about it is the hot is like the file cabinet that's under your desk that you
Mhm.
constantly go in and out of. So it's easy to get to, it's fast, easy, but you don't have a lot of space there, but it's expensive to have real estate close by.
Mhm.
Cool is kind of like the one down the hall in the basement. Easy to get to, but you don't want to go down too often. And archive is literally sending it out in the banker's boxes to some facility someplace. And when
Yeah.
you have to get it back, man, hope you know what you're looking for
Yeah.
because it's hard, it's expensive, you have to wait, it's not fast. Is that a
Mhm.
good way of thinking about it?
Yeah, absolutely. And one of the things that you can do with a lot of systems and a lot of software is build what's called lifecycle rules. So you can
Hmm.
say, like, okay, I'm going to write data into hot, and it's going to be there. And if I don't touch it in a certain amount of time, it's going to transition into cool. And once it's been there for a certain amount of time, it's going to live just in archive. And be able to maximize your spend on data based on what you're doing with it and what you're
Right.
going to need.
Got it. That makes a lot of sense. And and beyond that, is there any other considerations when choosing storage types?
Yeah, the other thing you want to look at is the performance for what you're doing. So object storage is going to be good performance for applications, but and they have to be applications that are written to support that. And most of them, most applications that can leverage cloud storage will work with any cloud provider. They'll have a key to work in. That is, if you've got an application that's doing that, that's going to be faster than and cheaper than trying to build a disk or file. File is going to be best for users. So if users are interacting with it directly, file storage is good, and block is best for servers. So if you are
Right.
trying to set up a server that runs software, you put block storage on it.
That makes a lot of sense. So, as always, we have a great question from Stefan Kaup.
Oh,
Uh,
awesome.
so, I've been asked about file sharing, uploading for businesses now that they are remote, where clients would have previously walked documents into their office. Is this best for a special platform? That's an interesting question,
Mhm.
Stefan. Unfortunately, I hate doing it depends, but in a lot of ways, I think that the file version, like a Dropbox or OneDrive or a
Mhm.
Google Drive, would be the ideal solution for that, especially with the sharing that you could easily share and track that file through its life cycle.
Mhm.
So you know who accessed it, when it was accessed, is logged in. So I think
Yeah.
I think that's pretty much the right answer for that one, JP. What do you think?
Yeah, no, definitely. And I mean, the easy way to it is that you're talking about file sharing and uploading from people. So people is going to be file shares because that's meant to
Right.
work with people. Really, you would look at object if it was a program and a block if it's a server. So
Got it.
for sharing files, we internally we use OneDrive and SharePoint all the time, but Google Drive works really well for that. Dropbox works well for that. Box.com works well for that. There's
Yes.
a bunch of them out there.
Got it. Makes a lot of sense. All right. So with that in mind, let's get to our next part.
Mhm.
Give me good use cases for cloud storage. Like, why would I use this over a server? I mean, we know that it's flexible, it's available,
Mhm.
the price point makes it comparable to local storage. But what are the great use cases here?
Yeah, especially now with everybody working remotely, working from anywhere, it makes it a lot easier for people to access data because everybody is using their own internet connection to the cloud provider's internet,
Right.
not their own connection to the office connection. So it removes a big bottleneck. It also makes it a lot easier to scale. If you only need a terabyte of storage, now you can get a terabyte of storage now. You don't have to plan for 3 or 5 years of how much data are we going to have. If you have a terabyte now, and then all of a sudden tomorrow you sign a big contract that you need to double your storage, you just double your storage. You just say, okay, I want twice as much now, and there you go, and you have it. So
Right.
it's very, very flexible.
That makes a lot of sense. I mean, also, I would assume web servers or host applications. This would
Hmm.
be a much more
Yeah.
redundant, resilient solution using this
Yeah,
kind of thing.
absolutely. If you're hosting a website and you have it in your office, you're relying on your equipment, your internet, your power to keep that website online. And if something like a hard drive failure could take the site offline versus putting it in cloud storage where it's very fast, it can be spread around the globe in different data centers. So you can get very, very low response times based on where people are located and build things out much cheaper than you would be able to do on your own.
That makes a lot of sense. That makes a lot of sense. What are limits? What's a bad use case? I mean, we talked last week. We spent a good time talking about storage arrays and
Mhm.
utilize them. I think it's important we kind of give out like why would you? Okay, it sounds great. Why would I ever use anything but this?
Yeah. So if you're looking for very high speed and very large storage systems, cloud as a primary is not really the best way to go. Thinking specifically things like high resolution video editing and video teams that are editing,
Right,
or if you're doing a lot of 3D design or rendering and these things, there are cloud systems that do all that stuff in the cloud. But if you're not fully transitioned to that, if you're still working on local machines, having that storage local is going to be much, much faster for those kinds of workloads.
right,
What we do is build like a hybrid system where the data lives locally for fast access, but it's backed up to the cloud. So you get the benefit of both. But
right,
for that, like I need to open this video file and work on it. If it's a 500 gig, 1 terabyte file and it's in the cloud, I have to download that file before I can work on it. And that could take time, and you pay for the time you're downloading and all this other
right.
stuff where really just having it local is a better option in those cases.
I agree. 100%. I mean, that's really the use case we're seeing constantly.
Hmm.
And one of the I think is really important in any of these models is that most cloud providers use a shared responsibility model.
Hmm.
So we talk about backup and availability and all this stuff, but you're still responsible for the data that you create on these systems.
Yeah.
So if something gets deleted, you're responsible for it.
Hmm.
The cloud providers only gives you X amount. They usually say 30 days or it's in the
It
settings, but yeah,
depends on what it is that you're doing. So, like Office 365, there's a default 30-day recycle bin when you can get stuff back from that. And after that, it's gone because you set it to delete. They're assuming you want to delete it. For other cloud services, that's not an option at all. Like, they don't give you that. It's just we're giving you a disk. Whatever you do with this disk is up to you. And it's up to you to build an environment that is redundant and is protected.
right,
And sometimes that's in the architecture, like making sure that you have enough backup built into it, or that you have servers in two different data centers. And sometimes it's in using third party tools to back up that data and move it somewhere else so that your data lives in Azure and AWS, or it lives in
right.
Azure and local, or however you want to split that data up.
Right, multi-cloud,
Mhm.
and you're responsible for the security of it, that sort of thing. So once again, it's important that we use the term shared responsibility.
Yeah.
It's what the cloud providers use. I know you've mentioned it a number of times in our Q&As. So I think it's really great that we can just kind of get it out there again. So I don't know, JP, do you have anything else for today? But there's
No.
a lot. There's like a ton of content for 21
Yeah, this
minutes.
is like a good intro to it. I mean, like each
Yeah,
of the areas of storage, there's a whole like well that you can get into with
yeah,
what they're good for, what they can do, what they can't do, those sorts of things.
yeah.
But I think unless anyone's going to post any other questions, I think we've covered most of the basics.
Perfect. I think it's great, and it's a good primer. Just understand what you're buying. If you're talking to a service provider or you're looking at these cloud solutions for your business, give
Mhm.
some ideas so that you're not having to spend so much time kind of understand the use case, which is really important.
Mhm.
So, with that, I'm going to say thanks a lot for some great information. We're putting a lot of content out every week. We really love to do it. We love getting the feedback from everyone. And we also put out last week a Open for Business webinar with some panel. Please take a look at it or download it and review the resource guide. And with that, I think our next session is a really super exciting one
Mhm.
that's close to my heart. Again, I love doing all this. It's about project management and how we developed kind of our own project management methodology around our needs and our clients' needs. And that's with our and that's with our one of our lead project managers, Christian Zapata. I can't wait to do it with him on Wednesday,
Yeah,
and I'm
it'll
really
be fun.
excited. It's gonna be a lot of fun. So
Yep.
please tune in on Wednesday at 10:30. We'll do with Christian and Marianne. And if you have any questions, please post them to our page, and we'll ask for a like on YouTube and or social, LinkedIn and Facebook. With that, I want to say thank you, and JP, thanks for
Thank you.
dropping this great knowledge. Super awesome.
Always,
Thanks a lot.
always fun.
Have a great day. Thank you.
Take care, everybody. Bye.